And now going to part B. Part B, we have the function y equals to 2x squared minus x plus 1. The formula for first principles states that dy dx equals to limit as h tends to 0 for the functions f of x plus h minus f of x all over h. So from here, we need to get the two functions f of x and f of x plus h. We need the expressions. But if you look here, we have function y in terms of x. So we say let y be the function f of x, which is true. Y is a function in terms of x. So we have a function in terms of x, which is y. Therefore, f of x becomes 2x squared minus x plus 1, which is the function y. So we have f of x to be written here. We are left with f of x plus h. f of x plus h. How do we get it? We use the function f of x. What we do is, where we find x, we put x plus h. So now in this case, we shall have 2. There is x here. So instead of x here, we shall put x plus h. Close the bracket. But x was squared. So we square this. Minus x. Instead of x here, we shall put x plus h. But since there are two terms, we open the bracket and say x plus h. So instead of x here, we have x plus h, and we proceed plus 1. Then we expand using one of these three methods, but we are using operation of brackets to save our time. This here gives us 2 into, if we square this, it gives us x squared plus 2xh plus h squared minus, if we open this bracket by negative, we shall have minus x minus h plus y. Now, remember these two occurs on the first term. So let us expand the bracket further by multiplying by 2. This gives us a 2x squared plus 4xh plus 2h squared minus x minus h plus 1. If you look here, there are no like terms. So this is the expression for the function f of x plus h. After getting f of x and f of x plus h, we simply need to substitute for them here. But to save our time and space, let us first subtract outside, because the formula says f of x plus h minus f of x. So this minus what? So f of x plus h minus f of x equals to, this is f of x plus h, which is 2x squared plus 4xh plus 2h squared minus x minus h plus 1. This is f of x plus h. But we are saying minus f of x. Where is f of x? F of x is here. It has three terms. So we open the bracket. So we have the 2x squared minus x plus 1. Close the bracket. Now, this negative here will make 2x squared to become negative. So negative 2x squared will cancel with positive 2x squared. That is 1. Also, this negative x here becomes positive, because negative times negative. So it becomes positive x. So this positive x here cancels with negative x. This positive one becomes negative. There is a negative term outside here. That gives us here negative 1 cancelling out with positive 1. That means the remaining terms are 4xh plus 2h squared minus h. Those are the terms that we are left with. We are left with this 1, 2, 3. Yes. So this is the difference of the two functions. So therefore, we say dy dx equals to limit as h tends to 0 for this is the difference of the two functions for xh plus 2h squared minus h over h in the formula. What do we do here? Let us divide all the terms by h such that we shall have limit as h tends to 0. If we divide by h, we shall have 4x plus 2h minus 1. Now we are going to turn h to 0. This implies that we shall substitute where there is h is 0. So finally we shall have dy dx equals to 4x plus 2 times 0 minus 1. This gives us here 4x minus 1. And that is the answer when we are differentiating from first principles. Before you leave your answer in the examination, check if it is correct. Just check side work. The function is y equals to 2x squared minus x plus y. Use the method of powers and coefficients. Therefore, dy dx here becomes 2 times 2 x squared minus 1 minus 1 times 1 x power 1 minus 1 plus if we differentiate the constant 0. This here gives us 4 x power 1 minus 1 x power 0. This is the same as 4x minus 1